for our third and last lesson of this unit, we are going to be solving radical equations. So just a few things to remember before we get down to the actual problem solving, and those have to do with some of our exponent and root rules. So first thing to remember is that a square root of something is actually just a fractional exponent. So square root of x is actually just x to the 1/2, because remember it says square root, there's an invisible little 2 there. If I have the 5th root of x is actually just x to the power of 1/5. So anytime you have any kind of a root, you can also write it as a fractional exponent. And the other thing that we need to remember from our root rules, from our power rules, is that a power, something to a power, raised to a power, so x squared cubed, which means x squared times x squared times x squared, we multiply the exponents. This is just x to the 6th. So that's important for us to remember, because if I want to somehow get rid of a 1/2, if I took something like x to the 1/2 squared, that would end up with, well, 1/2 times 2 is just x to the 1 is just x. So to get rid of a square root, I'm going to square. To get rid of a 5th root, I'd raise something with the power of 5. So that's just important for us to remember as we go through these solutions. So let's get down to the actual solving of equations. So for example, number 1, I'm looking at the cube root of 2x plus 7 is equal to 3. And remember that when I'm solving equations, I'm actually doing reverse GEMDAS. Remember that GEMDAS stands for grouping symbols, exponents, multiplication, division, addition, and subtraction. So when I'm trying to solve this, I'm going backwards. So I'm looking to see, do I have any subtractions? Well, what I've got is actually either, you could call it an exponent, you could also call it a grouping symbol. We're actually all the way down at this end. There's nothing outside that, so I've got to actually start here. But in other ones, I'm going to use this starting at this end, moving backwards. So again, taking this idea, this is a cube root, which means it's actually a invisible 1/3 power. Remember, this could be like to the power of 1/3. To get rid of that, I'm going to raise both sides of my equation to the power of 3. So if I want to do 1/3 cubed, that's going to multiply, that's going to go away. And kind of running out of space, but cube this, cube both sides of your equation, that will get rid of my cube root. So that leaves me here with a 2x plus 7, and 3 cubed is 27. Now at that point, I've just got a linear equation and I can solve it with all my normal things. So subtract the 7 from both sides, and I've got 2x equals 20, and then I can divide by 2 to get x equals 10. Now that seems like a likely looking answer. Oh, let's see if it checks out. I'm going to plug it back into my original equation. So I'm going to go, okay, cube root of 2 times, instead of x, I'm going to put 10 plus 7. Take that root line all the way out there, and I want that to equal 3. Well, let's see. 2 times 10, 20, plus 7, that's 27. So I've got cube root of 27. Is that equal to 3? You bet it is. I've found my solution. So go back here, box it. My solution is x equals 10. Let's try another one. Again, we're going to take this GEMDAS going backwards. So in this case, I'm looking for, do I have any addition and subtraction? You bet I do. I've got this plus 6 now outside my grouping symbol, so I'm going to start by moving that over to the other side. So I've got root x plus 3, 4 minus 6 was going to be negative 2. And then now to get rid of my square root, remember this is an invisible, or another way to write the power of 1/2. To get rid of a square root, I'm going to square both sides. Square both sides, and that leaves me with now x plus 3 is equal to negative 2 squared is negative 2 times negative 2 is going to be positive 4. Subtract 3 to get x by itself, and I've got x equal to 1. Again, I want to check, did this actually work? Do I get both sides equal to each other? So I've got 1 plus 3 under my square root plus 6, and I want to know, does that equal 4? Well, root 1 plus 3 is a root 4. Root 4 is just 2 plus 6. Hang on, does that equal 4? Does not. We have found an extraneous solution. So x equals 1 is extraneous, which actually means my final answer is there is no solution. And remember, this is just a reminder, an extraneous solution is a solution, an apparent solution, that must be rejected because it does not actually satisfy the original equation. And the reason that this happened in this case is because we ended up with this square root is equal to a negative number, but a square root, we always choose the positive root unless there's a negative written in front of it. So when I got to here and I was like square root of 4, well, I chose 2, not negative 2, and then my life didn't work out quite as simply as I'd hoped. So an extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation. And that's why we're doing all this checking, just in case we're heading up to extraneous solutions. All right, a couple more examples. Here we go. So again, thinking reverse GEMDAS. I want to move this 6 over to the other side first. Trying to get the square root all alone on its own side so that I can square both sides. So what I've got is square root of x squared minus 6x is equal to 4. Square both sides to get rid of that square root. And this is going to give me x squared minus 6x is equal to 16. Now in this case, not quite as simple as my linear equations from up above, but nothing we can't handle. If I have an x squared and an x term, that tells me I'm headed for some factoring. So move your 16 over to the other side so that I can factor this bad boy and get myself some solutions. So I've got x squared minus 6x minus 16 is equal to 0. Pull those apart into 2 parentheses, and I need x's in the front of both parentheses, and I need now 2 things that will multiply to negative 16 and add to negative 6. So let's see, factors of 16, 4 and 4, not going to give me negative 6. 2 and 8, well let's see, what if I have negative 8 and positive 2? That will get me my negative 16 and my negative 6 that I need. It looks like I found some solutions. This first parentheses is going to give me the solution of x equals 8, and my second parentheses is going to give me the solution of x equals negative 2. From here, I now need to check both of these, because it's possible that both of them might work, it's possible only one of them works, it's possible neither of them works, and we have no solution. So starting out with the x equals 8. Let's see, square root of 8 squared minus 6 times 8 plus 6, does that actually equal to 10? Well, let's see, 8 squared is 64 minus 48. That's going to give me 64 minus 48. I can't do that. Let me think. 4 minus 8. 10 minus 8. 16. That's going to give me 16. Root 16 plus 6. 4 plus 6. Yes, that equals 10. Check. Sorry, I should have written that all the way down. We have found that, yes, in fact, x equals 8 is a solution that works. Now let's check x equals negative 2. I've got the square root of negative 2 squared minus 6 times negative 2 plus 6. Does that equal to 10? Negative 2 squared is going to give me 4. Negative 6 times negative 2 is plus 12 plus 6 equals 10. And again, I have square root of 16 plus 6 equals 10. Which I saw before is in fact 4 plus 6 equals 10. Check. So in this case, both my answers check out, and I have 2 solutions. Life is good. Let's take a look at another example. Number 4. Now this time, outside my square root, I've got the plus 3 and this 2. So I'm going to again reverse my GEMDAS. I'm going to first move the addition subtraction term because I'm working from my way back this way. So first subtract the 3. So this gets me 2 root x squared plus 8x equals 9 minus 3, 6. And then I'm going to get rid of my multiplication division. So this 2, I'm going to divide both my sides by 2. Handy that. Then I've got square root of x squared plus 8 is equal to 3. Get rid of my square root by squaring both sides. So what have I got now? I've got x squared plus 8x equal to 9. And just like the last one, I'm looking to move my 9 over and factor. So I've got x squared plus 8x minus 9 equals 0. I'm running out of space, so I'm just going to move this up here. Hopefully you also have a little bit more room somewhere to work with it. We're going to do double parentheses equal to 0. X and x need things to multiply to negative 9 and add to 8. So let's see if that would be plus 9 and minus 1 will add to 8. And this is going to give me the solutions of x equals negative 9 and x equals 1. Again, let's just double check that math checks out, that these apparent solutions are actually real solutions. So plug that back in. 2, I'm going to do minus 9 first, so the minus 9 squared plus 8 times minus 9 plus 3, does that equal to 9? Step by step. 81 minus 72 is going to be just 9. I didn't need such a long bar. 9 plus 3, does that equal 9? Well, root 9 is 3, so 2 times 3, 6, plus 3, 9. Check, found one solution. Yay, I'm happy. Let's try solution number 2, which is plug in 1. So I've got 2 root 1 squared plus 8 times 1 plus 3, does that equal 9? Well, I've got 2 root 1 squared plus 8, that's going to be 9, plus 3 equals 9. Check, I've got the same thing over again. Both of them are solutions. Life is good. Alrighty, let's keep moving. Example number 5, I've got the square root of 7x plus 15 is equal to x plus 1. Nothing annoying outside the square root to move around, so my first step is going to be squaring both sides. And when I do that, when I square the right-hand side, I need to remember that this puts parentheses around. It's not just square the x, square the 1, it's square the whole thing. What that actually means is x plus 1 times x plus 1. Remember, squared means times itself. So when I square both sides, I'm actually going to have to FOIL or double distribute the right-hand side. So on the left-hand side, happy day, I just get rid of my square root. That was easy. On the left-hand side, x times x gives me x squared. X times 1 plus 1 times x is going to be a 2x. And 1 times 1 is going to give me plus 1. Now again, when I end up with a situation where I've got an x squared and an x term and another x term, I should be thinking I'm going to eventually need to factor, so I'm going to move everything over to the right-hand side. So I'm going to subtract 7x from both sides and subtract the 15 from both sides to get me equal to 0. So 0 equals x squared, 2x minus 7x is minus 5x, and 1 minus 15 is minus 14. Let's see if I can come up with two numbers that will multiply to minus 14 and add to minus 5. I think that will be minus 7 and 2. And then I will get from each of those, this first one is going to give me x equals 7, and the second one, negative 2. Let's go checking. Square root of 7 times 7 plus 15. Does that equal? Okay, now I've got an x on the other side. 7 plus 1. Well, let's see. This is square root of 49 plus 15. Does that equal to 8? Well, let's see. If it's going to work, this side has to be 64. So 40 plus 10, 50, 9 plus 5, 14, 64. You betcha. Square root of 64 is 8. Check. I've got an answer. One more time, this time with a negative 2. So I've got square root of 7 times negative 2. Plus 15, and I want to know, does that equal negative 2 plus 1? So I've got negative 2 times 7, that's negative 14 plus 15 is just going to be 1, square root of 1, and negative 2 plus 1 is negative 1, so 1 equals negative 1, that tells us my negative 2 is an extraneous solution. Not going to work. The only solution that is valid is the x equals 7, because the negative 2 is extraneous. So watch out for those. In this case, we still do have a solution, just only one. Example number 6, very similar to example number 5. Here we go with squaring both sides. So square this side, x plus 6 squared, remember that's x plus 6 times x plus 6, it's times itself. So on the right side, 2x plus 15, and on the left side, x squared, x plus 6 plus 6 times x is 12x, 6 times 6, 36. All right, move everything over again to the left-hand side. So I'm going to subtract 2x and subtract 15. I get 15 both times. Look at that. And I've got 0 equals x squared. 12x minus 2x is 10x. And 36 minus 15 is 21. Now I need two numbers that will multiply to 21 and add to 10, and I believe those would be 3 and 7, giving me the solutions of -3 and -7. So let's check and see where we get from there. So I've got the first one, square root of 2 times -3 plus 15. And I want to know if that's equal to -3 plus 6. 2 times -3, -6 plus 15, 9. And this is going to be -3 plus 6, 3. Square root of 9 is 3. Check, found one solution. On the other hand, 2 times -7 plus 15. Is that going to equal -7 plus 6? Well, on this side, -7 times 2 is -14 plus 15 is 1. And on the other side, -1, I've got 1 equals -1. Again, failed solution, extraneous, -7, and a -3 is my only solution. So you may be noticing a pattern that we can potentially get extraneous solutions when we end up squaring both sides with a square root. So even roots can end us up with problems, and the reason for that is we end up with something like this where we have 1 equals a -1, because when you square a negative number, it loses its negative power. You could call it its negativity. But it doesn't always work out that way. In the case of example number 3 and example number 4, we had 2 valid solutions, but potentially a square root can get us into trouble. One more example before you try them on your own. I've got the cube root of 12x minus 5 minus the cube root of 8x plus 15. Now, when I have 2 roots, the goal is actually to get one by itself on one side so that I can square or cube or get rid of it, and then we'll see what happens after that. So I'm going to move this minus cube root of 8x plus 15 to the other side by adding it. So this gets me then a cube root of 12x minus 5 is equal to, when it moves to the other side, it becomes positive, cube root of 8x plus 15. And then to get rid of a cube root, we're going to cube both sides. So cube this side, and that just cancels out. So 12x minus 5 is equal to 8x plus 15. Now this is a simple linear equation, so just collect your like terms and see where it goes from there. I'm going to subtract 8x from both sides and add 5 to both sides. And when I do that, 12x minus 8x is 4x, and on the other side, 15 plus 5 is 20. Divide by 4, and x equals 5. Now we're not done until we check, so I'm going to just use the space that's over here. Hopefully you have some space to work with too. Cube root of 12 times 5 minus 5 minus cube root of 8 times 5 plus 15, and I want that all to equal 0. So let's see what we get here. Cube root of, well, 12 times 5 is 60, minus 5 is 55, minus cube root of 8 times 5 is 40, plus 15 is 55. Cube root of 55 minus cube root of 55 equal to 0. You betcha. We have found a solution. Right, now it's your turn. 2 equations for you to give it a go, and then come back and check your answers. So pause your video now, try it, come back. All right, how'd you do? Did you remember that something cubed, a negative cubed is always negative? And did you remember that a -2 squared would be a +4? Hopefully you did, and hopefully you got to the answers. So, if you need a little more time to check what happened, pause your video now, and otherwise, good luck with your homework.